Good morning. We're going to go ahead and get started. Today's topic is QCing the engineered model, or 3D modeling tips, or a little bit of both. My name's Vern Danforth. Of course, I work here in the Production Support CAD office in Tallahassee, or the central office. In today's session, we're going to be covering a few topics, basically a brief F.CAD history, how we got to where we're at today, having a little bit of a discussion on 3D engineered models and what to detail as far as the various things within a model that you need to show. QA and QC as defined by FDOT according to the PPM, and then a QC review of the model, a checklist, and various tools to perform your QC with, quality control. And then a little bit of review on what is in the CAD manual for 3D deliverables currently, and maybe talk a little bit about futures and that type of thing. So as far as the history and the background, most of you know, some of you newer folks may not, but Florida DOT has been delivering a workspace on Bentley for a long time. It was based on the Geopack software, the legacy, what we're calling legacy Geopack software, which is a vertical application on top of MicroStation. And essentially it was for developing 2D plans, or for creating a planimetric and labeling it and cutting up into sheets and cross sections and, you know, different things for that. And of course the software was built, FDOT software was built to automate a lot of the plan production tasks as well as the Geopack tools. As you can see, this is just a list of all the different workspaces we've delivered over the years, starting with 2002 and then 2008, 2004. They're not in alphabetical order here, I guess, but or numerical order, I should say. Around 2011, and actually a little bit before that, we started this open CAD platform where we were developing our workspace on two different platforms, MicroStation and AutoCAD. Of course, Geopack and Civil 3D were the verticals. And both of those engineering applications were starting to work in a model-centric environment, in which case the model was produced before you started doing or alongside of doing any planned production. So we've been doing it now in one or the other for about, I guess, 6 or 7 years. So it's not like it's just something that we came out with yesterday. It's been currently under development for quite a long time. The contemporary software, OpenRoads or Civil 3D, is just like I said, it's model-based for designing models, and then the plans are a byproduct of what you generate in the model. Most of you are familiar with that already. As far as the contractors go, the contractors have been making models, the ones that have been using automated equipment, automated machine guidance equipment, robotic controlled equipment, have been generating models from our plans for several years, actually. Some of them maybe as long as 10 or 15 years ago. Their technology has basically helped them make money on projects. They don't have to stake out as much, it's safer, it's more controlled. There's lots of benefits on the contractor side. Prior to the DOT or DOT consultants creating models and delivering them, the contractors would essentially take our cross-sections and develop models from them. They would be as good as the cross-sections were, so they might be 50 or 100-foot cross-sections, and they would essentially try to fill in the details. And there's a couple of products out there that are really good at automating that really quickly as far as digitizing cross-sections and making 3D elements out of 2D plan elements and making models from them. So they've been doing it for quite a while. We're coming together with the technologies since designers are getting into modeling and contractors are using models. It only makes sense that the designers should be delivering the models. It would take away all that upfront work that they have to do when they want to work off a model for constructing the project. Which kind of brings us to today. Consultants, currently, you know, the scope that you negotiate is for developing a set of plans. And now we're talking about models, so we're also looking at adjusting the scope to produce the models and getting hours in there and getting compensated for building models as well. So we're going to talk about that a little bit. Of course, there's an office bulletin that's currently underway about how we move towards building the models, more specific guidelines about it, and that type of thing, which will be forthcoming. When is 3D model delivery required? It depends on whereabouts we're talking about. in Project Suite, which is where our different projects are programmed, there's actually a code that goes with a project that gets put in the 5-year improvement plan. And this 3D PR code. And if the project has been identified as a 3D PR, then it's supposed to be a project that is going to be created in 3D, and a 3D model would be delivered. Now, when it gets out to the district currently, that may or may not happen. It's kind of up to the districts at this point in time to decide, well, we're going to model this job or we're not. At least this is just from what we're understanding, because it's not always modeled, even though it has a 3D PDR. At least that's what we found recently. Now, that may change in the future, but that's kind of where it all starts. Now, if a district project manager requires that a model is created, it might be a turnpike district or District 7 or whatever, then it should be defined as such in the professional services contract that you work with. And we'll talk about how the scope of work guidelines that we're going to essentially deliver in the future will provide some of those guidelines as to how to estimate a job that has modeling involved in it. But currently, it's just going to be whatever the district project managers have negotiated with the consultants that were awarded for that project. And then we talk about what does the CAD manual define for deliverables. I don't know, it's been maybe 2 years at the longest that we've had a spreadsheet or a table in the CAD manual defining specifically what the contractors need for model delivery. In other words, the 3D deliverable files is what we call it. It's actually in a 3D deliverables folder within your project folder directory structure. And it's laid out specifically as to what exact files and what the naming of those files should be. And the whole purpose for that was so that the contractors, when they get a job that has a model created, they can just go to this one folder and they'll be able to get just the specific files they need to essentially load into their software or their equipment to be able to work off of. So they don't have to worry about taking the plans and making models from them. So that hopefully clears up some of the questions there. Okay, so into what level of detail? That's another question we get, is to what do we need to model? Do we need to model all the driveways, all the sidewalks? Do we need to just model for preliminary grading? Again, that's going to depend upon the job, and we'll be providing a little bit more guidelines in the future. And as you can see, this is just a sample screenshot of what the scope of work task would be. I don't even think it's in the 4 sections anymore. I think there's a whole new section for negotiating hours for building models. But as you can see, it's similar to the way we estimate current projects. Lower ranges for hours on certain types of projects, middle ranges for others, and upper range hours for more complex jobs. And then you can see it's broken up into different phases. So what you build for 30% is going to include so much per hour, 60%, 90%, and final plans. And again, this will all be on I'm sure there'll be a baseline for it, but as far as the details, that will be probably negotiated with the district project managers as far as what kind of detail they need. It may be that they don't want to detail out ADA ramps, or they may. It depends on, I guess, depends on the project. But that's something that we're hoping that the projects, when it goes to negotiation, will be estimated that way. As far as QA and QC, according to the CAD manual, quality assurance is what the central office does, and that is essentially setting forth CAD standards, CAD level symbologies, checking to make sure that files meet that. Our QC checker is essentially just checking to make sure that all of the FDOT standard CAD level symbology and so on and so forth has been assured to. And so we kind of take care of that with the workspaces. Now, quality control is defined as the responsibility of the district offices or by their agents, in other words, consultants. So it's essentially in your project management scope. You usually have a QC plan that you have to submit with your project, and a checklist of such that we currently use for just plan-based projects. And we're looking to give you some guidance as a checklist, as you'll see here, that you can start to use for when you're doing modeling and what to QC on a model. The example that I sent you is just what we've come up with. It should be vetted, through our project management office and through our 3D task team as far as any final list. But that's something that you can use in the meantime as a go-by, so to speak, and you certainly can work it out with your district project managers on your projects for that type of thing. The quality assurance, as you see here, basically if you're designing a project, you want to make sure you're using our current workspace, no matter whether it's in the Geopack environment or the Civil 3D, and that will help to assure the quality on what is delivered. So the workspaces, they both include this QC check tool, which is really a QA check tool when you think about it. As long as you're adhering to that and you're delivering files with almost 100% compliance, then QA is being done on jobs. Okay, so the next topic here is who's going to be reviewing these models. It could be a lot of different people, obviously. It could be the designers themselves, who's ever designing it, or the engineers, the engineer records on the job. So as you're designing, you might have an engineer of record needing to look at the model for different things. Could be QCing himself, project managers within the consultant office or within the district offices for internal projects. The district project reviewers, we foresee that they'll want to look at the models, so they'll need to have certain tools to be able to do that. Other agencies in the future, or even currently, FWA, anybody who's currently reviewing a set of plans at a delivery stage is going to want to probably start taking a look at the model along with the plans. So local cities and counties, permitting agencies, utility companies, and usually those other agencies or other entities are kind of looking at how does this project affect me? How does it affect our city streets? How does it affect the current utilities that we have out there? How does it affect the wetlands in the area or the watershed boundaries and that type of thing? So I think the whole industry is moving towards design models, and the different agencies are moving that way as well. So being able to look at a model, you can get a lot more data just from looking at a model more quickly than you would looking through a set of plans. So not in all cases, but in a lot of cases. Contract estimators, so both from the DOT perspective and actual contractors, they need to look at models. If we start delivering models, it's only natural that we would start making our quantities from models, and that may happen in the future, probably fast-tracked in the future actually. So estimators will need to see, you'll be able to just pick on things in the model and get quantities right off of them. And then of course we've already talked about contractors. They use the models to build from, so they're going to want to review them as well. And then let's talk about what do they want to QC, or what do they want to check. First of all, obviously the most obvious ones, does it look complete visually? In other words, are there any gaps in the model? Are there any spikes, any overlaps? Do the transitions, are they smooth transitions or are they abrupt transitions? Are you harmonizing, which is what one of the districts uses for basically meshing in slopes and driveways to the current conditions? So you might want to look at the existing conditions with the proposed conditions either overlaid on top or somehow merged in place to make sure that you don't have any issues with back of driveways or with slopes not tying down right or any of that kind of stuff. So there's a lot of things that you can catch on jobs just by looking at and rotating around a model and zooming in at places. You can see that the project has been designed to take care of a lot of these type of things. Normal checklist items, this is again just a list that I've started to compile. I mean, you really don't want to, you're probably not going to check horizontal curves and K-values on the model. You'll be probably doing that off of the geometry that comes in the XML files for K-values and curvatures and that type of thing. But other things you can check are pavement lanes, shoulders, curbs. Are slopes correct? Are the super elevations correct on the model? Do you have slope breaks, adverse grades or adverse slopes? Checking some of that stuff. Now, how do you check that? I'm going to show you here in a minute, but There's lots of tools out there to be able to actually not even have to have CAD software on your machine to check a lot of this stuff, just standard off-the-shelf products that are on most of our machines. Other things like clearances, utilities, drainage, signage, any of the other models that would work with your roadway model, you can start to create integrated models where you're modeling the utilities, modeling the drainage, modeling signage, modeling bridges. And the more we model, the more things we can check. The more things we can check for a complete, you know, a lot of different things you can check once you have models for everything. Other things like, are you showing depths correctly for pavement, sidewalk, base, driveways? A lot of this stuff should be checked in the model as it relates to the typical sections or even what the plans call out. Because this needs to be correct if you're going to eventually use the model for quantities. So you want to make sure all your depths and that type of stuff is correct. So the more of these things that we can start getting in the habit of checking now is it's only going to leverage our ability for quantities in the future. It's not just a pretty picture anymore. It's not just for a preliminary presentation of what's going on. It's for real engineering needs, from quantities to construction. This next checkbox here is, does the model match the plans, or do the plans match the model? That's a very important one, because at least in the Bentley side, we're delivering the plans still currently the way it's currently done, with 2D based planimetrics and profiles, and then actually cutting cross sections from the model. But you want to make sure that the model lanes match what you've got in your plans, because it's really two different models within the same design file. We've started to look into some tools for doing this, which I'm going to show you in a second. And then you want to check your 3D deliverables, because currently what we deliver, or what we require in the CAD manual to be delivered, is not the physical design file model that you create in design, or drawing model for that matter in Civil 3D. We're actually exporting 3D lines out, we're exporting XML files out, so we're actually, in a sense, dumbing down the intelligent model that we're building and making it a very basic file that we can deliver to the contractor. And the main reason for that, well, there's a couple, but the main reason is that the construction software that they use doesn't necessarily read in these intelligent models that are created with Geopack or Open Roads, or even Civil 3D for that matter. So they need to be kind of vanillaed down to just line work or XML files that they can import. And then once those are imported, then they can work off of those. In the future, that technology may get a little closer. They may be able to read in more intelligent files. We may be able to deliver something more constructible for what they need. So that technology is evolving as both the vendors and the contractors work together in this. But for the time being, we have specific 3D deliverables. Essentially, they're XML files and DWG files. So this is an example of a 3D engineered model QC checklist. Again, it's a beginning list of things that we would consider being checked. A lot of them are already talked about. That is included as one of your handouts, and you can feel free to start including those as part of your own company's QC checklist. And then possibly in the future, as this is more vetted out, we may have a more of a standard one that we want everyone to use. But for the time being, it's a work in progress. It's something you can start with, and it's just what we've kind of come up with here in the CAD office. So hopefully that might be useful to some of you. So before I go any further, I want to get out into and show you some of the things that we're talking about QCing. So first, I'm going to open up the current version of Geopack, and I'm going to show you a few things. So here's the model, a pretty complete model. I don't know if it's 100% complete. It probably is more like 90% complete. But some of the things you would look for, obviously, if you zoom out, you don't see any holes in this model, right? So there's no holes. You'd also want to check the line work. So we have tools for turning off levels. If you hit your F9 key, it turns off all the solids, so you can start looking at the line work that would get delivered. You want to check things like are there any what's called vertical faces or caves with your lines? For example, this traffic separator, in the standards it shows that this traffic separator has a vertical face here. Well, you wouldn't be able to deliver the 3D line work like that. So you want to go check your templates, make sure there's just a little horizontal difference between these lines. Essentially 0.01 feet is good enough, and that's so infinitesimal. It's only so that it won't, when it goes to create a top mesh of this or a final DTM, that it doesn't go from this line to the top line. It's actually going to go across here and then go up and then across, but it won't be a true vertical surface. It will have a very high slope on it, but essentially it's almost vertical. That's some of the things you want to look at. You want to check things like this here isn't good. This line here shouldn't be extended through here. It should probably trim back to here. And as you know, you can't trim these lines. Some of you that have already tried, at least in MicroStation, you can't delete out certain lines. So what you've got to do is you can always capture these lines in a selection set, save them out to a DWG file, and then a DWG file will let you trim some of this stuff back. So these are the kind of things that contractors are finding when we deliver our line work, is that, you know, this is really not acceptable to them, because when they go to create a terrain from these top lines, it tries to add in this extra break here, which we never really intended. And if you turn on the shapes again, you don't necessarily always see them the way we model certain things. Either that, or you've just got to get more cognizant of what we clip or what we create. For example, you can see that there's actually an overlapping pavement here, one that comes from the model and one that comes from the corridor. So the best way to do this would be to actually start your corridor back here where this intersection starts. So that's an example of an overlap that you would need to clear out of there. Other things that you want to look for in your model, if you're going to be detailing out to this is a good example of where this curb is actually flaring out in the plan. So you want to model that, and you also want to make sure that the shoulder and this curb kind of, you know, a shoulder's got a 6% slope down, whereas a curb is or a sidewalk is actually a 2% up. So you have to make sure that you transition the sidewalk down to the shoulder or the shoulder up to the sidewalk in order to give the contractor an idea how you want him to build this. Typically, we show him this plan, and then the contractor goes out and figures it out. I mean, this is supposed to be 6% off of the edge of pavement. This is actually a plus 2%. So there's a big drop off here, and the contractor currently has to sort of transition these slopes in here. So if you can give them any kind of guidance for that, the more guidance you can give them, the better. So this is a good example of the type of things you want to QC on a model. So I'm going to look at the other side here of this intersection and see how some of these have been transitioned a little better. So this is an example of where the sidewalk has transitioned down and the shoulder has transitioned not only out, but it's also transitioned up, so that you're getting a better idea of how you want them to build that. Other things, this particular model actually has the ADA ramps modeled in here. This is pretty simple. You just kind of have to drop down the curb through there, add the type C with backline there. So a lot of this stuff is modeled in your final models. Same thing with like these noses. This is a nose that is actually completely modeled. A lot of times our models are just either you try to model it with a template that's trying to essentially go perpendicular to a center line, whereas a nose really isn't perpendicular. It has its own radius, and most of the templates should be going perpendicular to that radius line. So those are some of the details. Things like islands. This island here has got a sidewalk across it, so you got sod here on one side, sod on the other, and then concrete in the middle. And that concrete has a thickness, and when we're thinking about quantities, we want to make sure that we're transitioning down and adding the specific details in the model for that. A lot of it's pretty tedious, but it's what we need to move to for modeling. So you can see some of the examples we're talking about. Now I want to show some other tools for QCing models. Obviously, if you're a CAD ninja, like a lot of us probably on this meeting are, this is easy for us to do, but it's not easy for just casual viewers of the model. So we want to look at some other tools. First of all, if you're up in either one of the Civil 3D or Bentley products, you can always go to File and Print. And when you print from a model, there's actually a 3D plot config file. There's an f.pdf file rather here. If you choose open here, you'll see that you have the option right here to print to 3D. If you print to 3D, you're actually going to create a PDF file that is 3D. And I want to show you what that one looks like on this job. So this is what you get here. You get a 3D model that looks like this. It looks just like the view that I had over there. And this view has a lot of different, I mean, the PDF file, this is just showing you what the Adobe version of it looks like, but there's several tools here that you can learn to use to QC a model. You can do that currently on your desktop today, whether you have Bluebeam or Adobe. You can actually receive and open up a 3D PDF, and all these tools become available to you. There's things in here like if you want to change the lighting, you can change the lighting on the view. If you want to change the background color, I think that's here. You want to change it to black, you can change it to black. A lot of this normal CAD functionality. You can go and turn on and off different levels. So if you turn on the model tree, you can see all the different levels that are out here. You can turn on and off all that stuff. You can change the shading of it. So right now I'm just looking at solid shading. I could change it to shaded illustration like that. And then you can go and do these rotations. You can zoom in on a model. You can actually drag and drop it. If you ever get lost, you can go back to this bit, but I was just trying to show you how you can pan with it. I think I need to hit the pan. So now you can pan and zoom. You can rotate the model like this and then zoom in on it. So a lot of the things that I was doing with just plain MicroStation you can do, and you can drag it, zoom in on it, drag it. So there's a lot of this kind of stuff you can do. You can also measure with it. So if you find this little measure tool, you can come out here, it gives you a little bit of notes here, but then you can go to some specific types of measure just between 2 points, and you can pick a line, pick a point here, and you can pick a point over here, and you can see what the width of that roadway is supposed to be. So if I pick there, it's somewhere around, you notice I didn't get right on that line, but it's somewhere around 29 feet, and place that dimension. I can check this, what is the width of this, so I can make sure that it's according to, you know, what the typical is supposed to be. So that should be right around 4 feet. Does my model look pretty accurate? Yep. So a lot of that kind of stuff you can do. You can also go and actually cut sections in the model. So you can cut sections by the z-axis, which is, if you're looking at a top view, that would be going up and down. You can do it about the y-axis, which is the y-axis, of course, is the vertical axis in this view. You can flip this so you're looking at one side or the other. And then this is just a, the offset is really just kind of showing you going up and down the y scale. And then you can, of course, rotate and look at what that cross-section looks like. You can do it about the x-axis as well, and look at cross-sections. So let's just look at a y, and then I'll go to this rotate view. And right now I'm seeing this clip, the cutting plane, but if I uncheck that, then I can do it like that, and then I can draw a little box, or I can zoom in, I can pan over and zoom in. So this would be a way that you could check depths. You could cut a section and then just go out here and measure the depth. And you could see, all right, let me go to my measure tools now, and I could measure between 2 points on my pavement and see what my depth is. So that tells me that that's close to 9 inches deep for the pavement. And I'm not doing it real accurate, but I'm just showing you this is the kind of things that you can do in a PDF. There's also some other products out there, Bentley View. So this is a vanilla version of MicroStation, and there's also a vanilla version of AutoCAD where you have the same capabilities if you want to get that on your machine instead of PDF. It's a little more user-friendly if you're a CAD user. You can do a lot of the things that you're used to doing with MicroStation. You can go and actually turn on and off levels in the Project Explorer here, and you can turn off different things if you need to. Of course, all the rotates. Now this one actually has my plan view, what was delivered for planometrics, as well as what was delivered for the model. Whereas when I did that 3D PDF, it's just delivering the 3D PDF file. And then there are other tools out here. So I showed you Bentley View. I talked about Adobe Acrobat and Bluebeam. Both the Autodesk and Bentley are delivering these web-enabled viewers so that you can publish models to the cloud and then actually have a lower-end computer like a tablet, iPad, or a Surface, or I don't know if Surface is really low-end anymore, but iPads and some of these Android devices will now let you view a produced model of your model, if you will. So in Bentley, they call it an iModel or i.dgns, and you publish it to the cloud. If you have that, then you can use this Bentley Navigator tool, which is similar to what you have with MicroStation, but not really. The tools are more like what you see in the Adobe Acrobat. You have like maybe 12 tools to use to view and markup on a model. Same thing with OpenRoads Navigator. It's the same thing, but it allows you to look at essentially when you produce an OpenRoads iModel, it has more intelligent data. It has the features, and this is kind of where we're going to as far as delivering models that have more intelligent features on it that the contractor can consume. So these are just some of the tools that you can use to QC a model. Two more down here, and actually there should be three. I want to show you one other one. If you have access to any ag tech software that the contractors, a lot of them use ag tech to build actually models. It's really good at taking a paper set of plans or a PDF set of plans and building a 3D model from it, because it can digitize very quickly. It can create, it can digitize cross sections and connect the dots and basically make models. But it's only as good as what you're showing in the plan, and they're getting real good at it. The other one here is Trimble Business Center. They also have the ability to create models from plans, and both of them also read in the XMLs that we're delivering and the 3D lines that we're delivering, so it's more automated than that. So you can also use those to kind of QC to make sure that what you're delivering and what they're receiving is, what you're intending on them to use. So those are some other tools. I mentioned that there's a third one, and that is in our workspace. There is, if you look at your workspace folder, like in my case, it would be my f.ss4 folder. Let me just go to my desktop here and show you. Got a lot of stuff open here. So in my f.ss4 folder here, there's also another tool here, which is this Land XML Visualizer. And this is a tool that we started delivering, I don't remember, f.ss4, some version of Civil 3D. And essentially, it's just exactly that. It's a 2D visualizer of XML files. So you can file open, and you can go to your project and look at your project. Like in this case, it would be this one. There should be a 3D deliverables, and if you had any XML files that you had created, you could click on those and view them, and it would view your alignment files, your profiles, your surface XML files, and then you can toggle on and off different things here, and you could actually use them. And so this was something that was created in-house to just do a simple visualizer. Is what I'm exporting something that can be consumed by any third-party product to view XML. So that's what this is really validating, so that you know that it is a valid XML file. So that would be another one, this XML, the one that's delivered with our workspaces. Actually, that was my next slide there. So the QC is the Land XML Visualizer. All right, so then the last thing here I wanted to talk about was what is delivered to the contractor. And in the CAD manual, essentially, there's a table in, I don't remember what chapter it is, chapter 8, I think, possibly, that I should have a screenshot for you, but most of you, it's in the chapter 10 of your design and 3D modeling manual. One of the very first pages is a screenshot of what's in the CAD manual. And essentially what that's giving you is specific guidelines as to how to name the files that you put in your 3D deliverables folder. You're going to put them in there for your alignments, for your existing and final surfaces, and that's the essentially the skin or the top surface only for existing and final. And then you're going to deliver both 2D planimetric lines and 3D break lines in either DGN or DWG. Most of the software that's being used by contractors can accept either DGN or DWG. Originally they were just DWGs because that's the more common format in the industry, but I think some of them are now accepting just vanilla DGN. You can't have all the features on them, you can't have all the intelligence on them at this point. And then also, I believe there's a couple of Trimble and Leica now are accepting the ICM files, which are what is exported from OpenRoads that does have the intelligence. That's what's being you can see in OpenRoads Navigator and such. And that's really where the industry is moving, to where we can deliver more intelligent models for them to estimate off of and build off of. But in this interim time, these are the vanilla files that we're asking you to deliver. In the future, we haven't given a whole lot of guidance on the 3D drainage network, but the tools are there. If you use SUDA and you've modeled with, or you've created a GeoPack or ASAD drainage network, it will consume the GeoPack network, plan network, or if ASAD, you'll have to basically redraw it with the sizes that you've designed, but then it will actually create a 3D model. In the future, if you use the new versions of GeoPack or what's called SUDA, that has the analysis and the modeling and the plan capabilities, just isn't, it's a little shy on the production as far as the sheets, then that will be integrated with your roadway model. There's also the bridge modeler, which Bentley delivers, and I'm sure there's a comparable one on the Autodesk side. Utility models are really pretty easy. If you can get 3D utilities from the utility companies, or if you can at least get them laid out and verified depth-wise or height-wise, you can start modeling your utilities. Now, in the future, signals and lighting and signing, mainly those are for the foundations, just to check conflicts below ground, making sure that you don't have, a proposed, some sort of utility going through a foundation that you're proposing, and or other things that are subsurface. Also for obviously modeling and quantities in the future. We can get square footage or square yards of panels, or length of lighting conduit, anything that's more accurate in a model, obviously, than what we're estimating currently. In summary, this QC list is currently in development. These are some things that we've identified. As more and more things are brought to our attention, this list will grow and become more robust. We're staying abreast with what other states are doing, going to different national meetings, whether it's HEAP or some of the FHA, staying involved with the everyday counts, and so we're keeping abreast with what other states are doing. We're all kind of in this thing together, and I think Florida is probably right up there with the front of the pack. We may not be the leader at this moment, but we're right up there with the front of the pack as far as this whole technology, and so we're learning from each other as we go, but it's a work in progress. It's maturing day by day. If you have any specific questions or anything that maybe wasn't addressed today that you've been thinking about, feel free to shoot us an email. If your project manager is asking questions you can't answer, feel free to have them call our office. We'll try to give them whatever guidance we have. Can you measure areas and volumes? Yes, there is a way. You can do it within the GeoPack environment simply by, if you go to a model that has information in it, if you click on an actual shape, like in this case, this is the cut slope that represents this model. If I click on it and just look at the element information, it's going to have the surface area there in the geometry section. So there's the surface area of that in square master units. So that would be 17,000 square feet for just that slope right there. That can be converted to square yards. If it is a component that actually has a volume, if you click on it, you get the same data. Like, I'm going to click on the top of this pavement, and it goes from wherever this particular section is on this project. So it's this whole lane on this corridor from the beginning of the job all the way to the end of the job. And it's giving me not only the top surface area, which isn't, well, you could use that for your the square yards of asphalt, but it also gives me the specific volume based on the depth right there. So you can view that right directly from the model. Now in Adobe, I think if you click on the section, there may be a property on it. I have to figure out where the right one is. If I go to here, actually it's this one right here. If I click on this, I believe there is a properties that you can view on it, but I don't know if it's as detailed as what you're getting in the actual MicroStation tool. Same thing with Bentley View. I believe if you click on this same lane here and go to the edit information, I believe it might be in Project Explorer here on certain things that you'd click. But I'd have to, actually there it is right there. So if I click on this again, if I go to element info, it's the same data. So there's that same information in Bentley View. That would be the same for any like Bentley supported app. So for example, Bentley View, Bentley Navigator, Open Roads Navigator. You wouldn't see that in either of these two because we're just delivering the 3D skin surface for that matter. Measuring tools, there was a question, how can you check cross slopes in the PDF view? So in the PDF view, I think it's only giving you measurements just like a linear measurement. I don't believe there is actually a slope measurement in this one. We've had some discussions with Bluebeam and with Adobe about maybe making a more robust set of tools in this case. So the way that you can check slopes in a model that's delivered, from here is there are tools within Open Roads where you can just simply measure with Civil AccuDraw. If you turn on Civil AccuDraw and you're looking at, for example, station offset, if you click in this view here, it doesn't give you specifically the slope, but you can get XYZ just by placing a point or doing an analysis between 2 points. So for example, if I wanted to place a line, it's tracking station offset, and if I just set the baseline that I want to reference off of to here, now I'm tracking station offset in the plan, but when you go over to the model, you can actually get station offset in the model as well. And if you were in a cross-section view, let me open up a cross-section view real quick. I want to show one more thing here anyway. If I opened up a cross-section view, let me turn off this and open this model over here. And once it processes this, I can also do station offset and elevation in this view as well. So as I move forward, and let's say I want to check an elevation, I can actually go into this model and actually it's going to give me elevation data as well. First I have to click here and then place it. So now if I come over here, click this view, it should be tracking a station offset. And I've had it get me the elevation before. I'm just not sure why it's not doing it at the moment. I have that recorded in a webinar. If you have questions on that, you can do that. But while I'm here, I wanted to show one other things that we're doing to check the model lines versus the plan lines. Is we're teaching you how to enable this feature to draw the 3D model lines on top of your plan lines. Essentially, we're basically drawing them back on top of it. Normally, we lay out the plan work first, we create our corridors, and we use the 2D lines to control where the 3D lines are. And then in order to verify that, sometimes, the ranges aren't working right, or, you might want to just double check to see, does the model actually match the plans, and do the plans match the model? Well, one way that you can do it is by going to the reference files. There's always a 3D reference file that you can turn on, and it's going to show underneath there. However, it's kind of hard to differentiate between where is the model lines because it's kind of the same color. Even if you use F5, which dims it out, you might see them, you might not catch them. So one of the things that you can do is enable the features of the 3D line work to actually draw back to the plan work. And that's something that's done in the Project Explorer. If you want to learn how to do that, I can show you in Project Explorer, but essentially it's going to draw back these magenta lines anywhere there's a line in the model, and you can just check on certain ones. So in this case, I've only turned on my edge of pavement lines, my traffic separator lines. If I wanted to turn on, for example, my sidewalk lines, I could go to Project Explorer, go to the Civil Standards, open up the design file, go to the feature definitions, and find the 3D lines that are being drawn in this model. So for example, these are all the ones that are currently drawn. If I wanted to see where the 3D sidewalk lines were in relation to my planned sidewalk lines, I would just go to this sidewalk PM feature, go to the properties, and then there is this property here that you can enable, which is create template geometry. And if you just double click on it and make that true, it's going to draw these construction magenta lines as soon as the corridor is reprocessed. So then all I'd have to do is go out to this corridor and reprocess it, and then you would see the magenta lines on top of the sidewalks, and those are being put on a construction lines level right now. In our next release, we might have some QC levels for different things, like QC pavement lines or QC sidewalk lines or QC traffic separator lines. Typically, we're only going to enable this feature for things that we normally draw in the plan. So here now you see that the purple lines are in fact going on top of my 2D lines. I can toggle just by doing my F7. I can turn on and off different things like that. And then if you don't want them, you can just go turn that feature back to false. You won't see them. But it's just a quick way of doing a validation of what are my model lines matching my plan lines. And anytime you don't see, like in this case, I'm not seeing, this is a widening line, so I'm not seeing where my edge of pavement is stretching out to there. So this is definitely a bust in my model. I need to add this as a corridor reference, which I currently don't have. And as soon as I do, then it will pop that line out to there. So just to show you that I can do that, I'm going to add that to this corridor and data point, and then it will reprocess my corridor, and that line should pop out to there because that is an edge pavement line. Give it a second to redraw, and now you see that that's been adjusted. So right away I was able to QC the line work that I included, and I was able to fix my model. Okay, only way to check station offset elevations using Open Roads, right? That's correct. Actually, you may be able to do it in Open Roads Navigator. I haven't seen what the latest tools are for Open Roads Navigator. I think they were trying to add that to that though. Will the QC check in our CAD MicroStation software be enhanced to capture the 3D conflicts instead of just 2D elements? It already does. It's not really conflicts, but the QC check, what it does is it's checking to make sure that the levels that you've drawn the model data on is where we want you to draw them. As long as you're using the templates that we deliver, you're going to meet QC for your model. It's when you start going rogue with making your own templates and not using the same features that we're using for things like sidewalks and pavements and feature names for points, that's where you're going to end up failing your QC on your model. But we're already checking the default 3D for the models that we want you to display things on. And it's essentially, if it's a shape, it should be a PX. If it's a line, it should be a PM level. Anything else shouldn't really be in this default 3D. Hopefully you've gotten some ideas today that be helpful for your QCing. Again, it's a work in progress. We're going to have to start sharing different ways of doing this. Hopefully you've got a few things to start with, and feel free to share any of that with our office. Have a great day. Thank you all for attending.